Welcome everyone. In this video I would like to discuss this DC-DC converter again. So this is this SZBK07 DC-DC converter. This one already has the potentiometers removed. This is a brand new part. I even have the package for it. So why I want to discuss this? So this is a very nice DC-DC converter. It takes 6 to 40 volts on the input, and it can give 1.2 to 36 volts on the output depending on the input parameters. And there are two trimmer potentiometers here, one for the current and one for the voltage, and you can regulate the output in a very nice way and in a very, let's say, precise way. So this is quite a nice instrument, and you can run 20 amps through this thing if you can cool the heatsink properly. The manufacturers usually recommend you to run it up to 15 amps, and if you need that plus 5 amp, you should have an active cooling, such as a fan. So we had some discussions in some of the comment sections in one of my videos, and we were talking about the controlling of this device by a microcontroller. So the idea would be to replace this trimmer potentiometer, this with a multi-turn screw, with a digital potentiometer. But that cannot work. And why? So if we look at the back side of this circuit, then we can see that the output is directly connected to the trimmer potentiometer. And that's the first and basically the biggest issue with this kind of idea, to replace this, let's say, analog potentiometer with a digital one, because most of the digital ones can only handle 5 volts. So if you go above 5 volts on the output, which is quite probable, because yeah, if you have something which can provide 36 volts, why would you stop at 5 volts? So, and also you will probably need something more than 5 volts if you are using such a high performance device. So you will most probably go above 5 volts and you will immediately kill your digital potentiometer. So that's not really a good way to go. So there are some digital potentiometers which can go above a certain voltage, which is more than 5 volts, but still they can be expensive or more difficult to obtain. So this is not a viable idea, in my opinion. So in order to be able to modify this circuit, let's go through some of these parts and understand what happens. And for that, I will just use this multimeter, put it in a continuity mode. So it beeps when two things are connected. And let's go through the connections. And on this corner of the screen, I will put a more close-up picture of this panel, so you can see what I'm doing. So what I'm doing now is that first I just mark the positive side of the output, so you can see that this is the positive side. So let's put a plus here, so I just know that this is, let's say, a reference point. So we start from that point and we go down to the potentiometer here, and yeah, it is connected. But it's not connected to the rest of the potentiometer pins. But the output voltage should also go back straight to the chip, to the pin number 10, which is on the left corner down here. So if I poke that pin, the multimeter should beep. And there you go. So we have a direct feed of the output voltage to this chip, and it goes into a potentiometer, basically this guy. So now we are what we are looking at is basically like this. So this pin is connected to the output voltage, and that's what it beeps. So let's go to the pin number 2 and see if it is connected to something else. So I go to the middle pin, which is, let's say, the Viper, and then we can discover that if I tap the pin number 3, they are in connection. So that means, I show it in a closer way, that pin number 2 and pin number 3 are connected together. So this potentiometer works as a rheostat, which means that this, in the circuit, this acts as a variable resistor, because yeah, you connected together the Viper and the, let's say, ground connection of this pin, of this potentiometer. Because the other way is that, let's say you have a potentiometer like this, you have the positive voltage here on the pin number 1, on the pin number 3 you have the negative voltage or ground, and then on the Viper you can measure a voltage difference between the ground and the Viper pin. So basically you use it as a voltage divider, which is the other mode of a potentiometer. But in this way we don't have it as a voltage divider, so nothing, let's say, comes out from the middle pin, but it is rather a variable resistor. So let's see where that variable resistor goes. So I tried to poke the solder nicely and then look around, and I see the trace that goes down to this black part, which is a diode. So let's see if it's the reality. And yes, it goes there, but then there are other components which are in connection with that node there. So we have this C13 capacitor, C14 capacitor as well, and seems like that's all so far. So once again, from this part we go and we see the diode, and then we see a capacitor, another capacitor, and pin number 8 on the chip. And the pin number 8 is the feedback. So basically, almost straight from the output voltage through a variable resistor, we go to the feedback. So that means that here we drop the voltage and the current, and we feed that into the feedback pin. So we have to do something around this part in order to be able to, let's say, change the output voltage with an external device. So what we should do is that we should somehow manipulate the other side of the potentiometer, so that side where we have the two pins connected together. And for that we have a very nice trick. So basically we have to get a resistor, and the value of the resistor depends on the output voltage that you want to reach, and also the voltage which is available on this side, or more precisely the voltage range which is available on this side of the resistor. What I mean by that is that what you will do, or what we will do, is we put the resistor on one side of this connection. It doesn't matter if it's pin number 3 or 2, but on the, let's say, output or the other side of the rheostat. And then on this side we feed a voltage to the resistor. So there will be something appearing on this side of the circuit. So in order to do that, I will remove this potentiometer, and I will put this kind of potentiometer in a breadboard with some known value of resistor, and I will see how to change the voltage. And our goal is the following. So now, by using this kind of method, we can go back to the digital potentiometer. And why? Because with the digital potentiometer we can restrict ourselves in between 0 to 5 volt. And based on that voltage level, we can say that, okay, we pick a corresponding resistor, which can help us to cover that voltage level. And then that will be used to control this thing here. So I will assemble a circuit with this thing, and we will see what we can do. So I connected everything together, and then you can see the breadboard and the wires. I will make the drawing of this, but basically what you can see is that the blue wire goes from the output of this circuit to one side of the potentiometer, and then the red wire is connected together with the wiper and the other side of the potentiometer, which is also connected to a 10 kilo ohm resistor, and that will be, or it is connected to a power supply. And this will be a power supply between 0 and 5 volts. And remember that this potentiometer, this is what I removed, is a 100 kilo ohm potentiometer. So these are like the rough values if you want to control your circuit with a voltage between 0 and 5 volts. But we will see everything. So I showed you this, but I will also make a drawing. So don't forget to visit my website and check the drawing there. So now I'm using another voltmeter there just to monitor the output voltage. So this is connected now and it's stable. So now there is nothing visible, I think. So this should be visible. And this is nice and clear. So I turn on the power supply for this converter, so these two wires, and then let's measure it. So you can see that the input voltage there is 11 volts, and we have a slight drop on the output, and this is the output voltage, so 10.54. And now I just turn, and there is 0 volts here, so I haven't turned on the power supply for this resistor. So now I just use the potentiometer as I would turn this trimmer here. So I turn it counterclockwise, and you can see that I'm dropping the voltage. And it's quite sensitive, so maybe this 100 kilo ohm is a bit too much, but it works. So I turn it very carefully, and then you can see that I can modify the voltage. And now I want to show you somehow that I already reached the top of this thing. So I don't know how much it is visible, but I try to make it more visible. So I keep this rotating, and you can see how much I rotate it. So this is now 180 degrees of rotation, and the output voltage haven't changed. So first of all, you should make sure that your potentiometer is just at the, let's say, boundary where you can start to decrease the voltage. So when you start to decrease the voltage, you should stop there with this trimmer potentiometer there. So that's the first step to set up this system. So now I'm going back counterclockwise, and I dropped. So you just seek for the maximum voltage that you can reach, and as soon as it starts to change, then you try to go back. So we have to find our way back to 1.5, let's say. So this is set up, and this is now on the limit. So if I start to rotate it in counterclockwise direction, then I will drop the output voltage. But if I start to rotate it in clockwise direction, nothing will happen. So you have to find that limit yourself. And yeah, you can leave this thing in. You don't have to desolder it, but for me, for this demonstration, to be able to demonstrate it, it was easier to use the cables. So now we have this limit set up, or boundary. So I we'll turn on the power supply, and on the power supply first I apply 0 volts. But now I start to increase the voltage by very small steps, and by very small steps I mean 0.1 volt. So I just need a piece of wire to make it more easy to measure the voltage with this voltmeter, because I ran out of these clips. So I put this here, so at the same point where we have the let's say input for the resistor, and I just put it at some random part, and this will be our positive side, and the negative side is there. And you can see that the voltage now is 10 millivolts. And I haven't turned on the power supply, which will feed voltage here. So I turn it on, and you could see a small jump in the voltage, because there is now 40 millivolts. So now I start to increase the voltage here. So now it's 1 volt, and you could immediately see the drop here. And there you see it's 1 volt. So now I go to 2 volts. So now the output voltage went down to 6 volts. And indeed we have 2 volts, quite precisely. So 3 volts. You can see 3.01 and 4.2. 4 volts. And you see 4.018 and 2.3. And we go 5 volts, which will be our maximum voltage that we can provide with the digital potentiometer. So 5 volts. 5.025. And then we pretty much zeroed out the output voltage, because now what you see is 286.6 millivolts. So now I go slightly below 5 volts, let's say 4.8. So this should be 4.8, and we have half volts on the output. Let's see. So you see 4.8 and 0.68 watt as output. And just to show you that I haven't modified anything with the input voltage, that could see, but you can see that the input voltage is indeed high, so 11 volts. And I can further prove you this, that, okay, let's go down to 4.42 volts, so that is here. You can see 4.45 almost. So this is our output voltage. And now what I do is so you see 11 volts. Now it's 18, 26, and the output voltage is still stable, more or less. It's just the connections of the breadboard. This is not reliable, but yeah, you see that the input voltage is 26 volt, and yeah, we still got the same value on the output. So let's go back to 11-ish volts, just to show you. So 11.15 volts. So we still get the 1.4 volts. I previously had some problem with this breadboard, so I should replace it to some better thing. But you can see that it works. When you see that the voltage is jumping up to 10 volts, or basically the input voltage, it is happening because then the connection here is just ceased to exist. And then, in fact, if you remove the voltage feed here, now I turned off the power supply, then you should reach quite close to the input voltage. Yeah, I quickly soldered this just to show you that it works. It's only the crappy connections. So I remove the power supply. So here we do a trick. So this goes in. Then I bend it 180 degrees. And I bend it back. So it comes back and goes there. And this will be easy to solder. So the quick troubleshooting is done, and it was an easy job. So as you can see here, one side is connected here, and then these two are connected together, and we have our 10K resistor here. So I just put everything in this way down. Now we have the input voltage, and let's see. So here this is okay, and now I turn on the power supply here. And there you go, 1.6 volts. So it was only just the bad connections. So now I don't modify anything here. I just modify the voltage here. So I go down to from 4.42 volts to 3.42. So I jump 1 volt. Sorry, I moved in the other direction. So now we have 5 volts. So 1 volt drop again. Now we have 9 volts. And in fact, you can change the potentiometer just to the limit, because now it's not on the limit, as I can see. So then you can utilize the whole 5 volt range. I will try to move it in that way. So this is barely below the top or the ceiling of the range that we can reach. So I turn on the power supply, and we are at 0 volts. So this is the max. And now I go 0.01 volt up. Still nothing happens. But now you can see that it is changing, and I am at 0.07. Look at this. So I put this thing in the breadboard so we have some mechanical stability. So let's check the input voltage. So now I have this clip here and the ground, and indeed it's 74 millivolts. So now let's go to 0.25 volts. And you see that there is a drop, 253 millivolts, so it works. So now I go, let's say 3.25, 1, 2, 3, there, and you have, this is the output voltage. And you see 3.26 watts, so it works. So this works quite nicely, as I can see it. So once again, I explain this thing so you understand it well. Maybe on this circuit. So you have this circuit, and originally you have the two potentiometers in it. Here, there's a third unit. So you have the two potentiometers. You don't care about the CC pin, you just put it to the max if you don't want to limit the current, of course. But for this application, where we just control the current by limiting the voltage, you remove the CV, or alternatively, you go to the other side of the potentiometer, so pin number 2 and 3 of the trimmer here, and you put a 10K resistor there, as I did it here. So then that 10K potentiometer, or sorry, 10K resistor comes out. So let's say it will be here. You solder it here. I don't know if it's visible. You solder it there. And then you can apply a voltage on the other side of this thing, something between 0 and 5 volts. And then you will be able to cover the wall voltage on the output. And how to provide that 0 to 5 volt voltage? It's very simple. Now you can use a digital potentiometer, which works between 0 and 5 volts, and use that as a voltage divider and connect this pin to the wiper of that digital potentiometer, and with that you will be able to control the voltage, the output voltage of this digitally. But this video is too long for that. So if you need exact instructions for that, wait for my next video. I will release it very soon as well. But basically that's what you have to do, is that you just control the output voltage with a digital potentiometer. So in this video I just showed you how to do this like semi-analog way. So we just used the wires instead, and I got rid of the trimmer potentiometer, and I just used the regular potentiometer here. And you have to find the limit where you can start to change the actual value of the output voltage with this potentiometer, or the potentiometer which is in this board. And after you found that, then you can start regulating your voltage, your output voltage, with the voltage attached to this side. And for this demonstration I just used the second power supply to power this with different voltages, and you could see that by increasing the voltage here I could decrease the output voltage, and the other way around, if I decreased the voltage here, so the less I interfered with the circuit, then the voltage on the output increased. So that's all. And yeah, in the next video I show you how to extend this to make it digital. So yeah, basically this was all the circuit. Check the description down there, because I put the website link in the description, where you can find the drawing for this, yeah, very simple connections. And then I also put a donation possibility in my profile and on my website as well. So if you feel like that my projects and videos are helpful for you, feel free to donate, but it's not mandatory, and you should always make sure that you have all the money for yourself. You bought everything, and yeah, so I'm not begging for money. As you can see, I can do the projects, but for example, if I can buy better breadboards and stuff like that, I can provide you better quality content. But once again, it's not mandatory. You don't have to feel obliged to do it. I just mentioned that now we have that possibility as well. So don't forget to subscribe, please. Once again, check the description, because all the helpful files and pictures are there. And see you in the next video.